Beneath the surface of Northeast Asia, a dormant giant is awakening. Mount Paektu, a tranquil mountain on the border of China and North Korea, has begun to reveal its secrets. These revelations come in the form of unusual seismic waves rumbling through the earth, hinting at a potential for chaos. Gases escaping from deep within the volcano add to the concern. These gases, a mix of sulfur dioxide and carbon dioxide, indicate magma rising from the depths. The scientific community is on high alert. The signals from Mount Paektu are growing stronger and more frequent. They remind us that this is no ordinary mountain. It is a supervolcano, capable of eruptions far beyond any in human history. The question is not if, but when, this giant will fully awaken. The fate of millions could be at stake. The potential for devastation is enormous. Yet, amidst the concern, there is hope. Scientists, equipped with advanced technology and a spirit of international cooperation, are working tirelessly to uncover Mount Paektu's secrets. Their mission, to predict the unpredictable and prepare for a potential catastrophic eruption. The signals from the depths are a warning. It is a warning we must take seriously. The time to act is now. Mount Paektu is no ordinary volcano. It holds the title of a supervolcano, a term reserved for the most formidable volcanoes on the planet. Supervolcanoes are known for their capacity to produce eruptions of staggering magnitude, releasing over 1,000 cubic kilometers of material in a single event. These eruptions are not just explosions, but cataclysmic events that can reshape continents and alter human history. What distinguishes supervolcanoes is the immense volume of magma they can store and release. Unlike typical cone-shaped volcanoes, supervolcanoes often appear as massive calderas, vast depressions in the Earth's surface formed by previous super-eruptions. These calderas act like pressure cookers, accumulating vast reserves of magma over millennia. When the pressure finally surpasses the strength of the Earth's crust, the result is an eruption of unmatched fury. The impact of a supervolcanic eruption extends far beyond the immediate blast zone. The vast amount of ash and sulfur dioxide released into the atmosphere can trigger global climate change, leading to volcanic winters that can last for years. These winters, marked by reduced sunlight and plummeting temperatures, can devastate agriculture, disrupt ecosystems, and cause widespread famine. Mount Paektu, with its history of violent eruptions and its current state of unrest, serves as a stark reminder of the immense power lying dormant beneath our feet. It is a force that demands our respect, our attention, and our unwavering commitment to understanding and mitigating its potential impact. The year was 946 CE. Life went on as usual, unaware of the looming disaster. Then, Mount Paektu erupted. This was no ordinary eruption. It was the Millennium Eruption, one of the most significant volcanic events ever recorded. The eruption, believed to have reached a magnitude of 7 on the Volcanic Explosivity Index, unleashed an unprecedented force. It expelled an estimated 100 cubic kilometers of material, covering parts of Asia with a thick layer of ash. The sky remained dark for months, as ash and sulfur dioxide filled the atmosphere. The impact was felt across vast distances. Historical accounts from China, Japan, and even Greenland noted the strange atmospheric conditions and climate changes that ensued. The Millennium Eruption stands as a stark reminder of Mount Paektu's potential for destruction. It highlights the immense power lying dormant beneath the serene facade of this volcanic giant. The eruption reshaped the landscape, forming the caldera that now cradles the stunning Heaven Lake, or Tianchi, a vivid reminder of nature's formidable power. The Millennium Eruption is a tale inscribed in ash and ice. It is a story that continues to captivate and caution, reminding us of the fragile balance between humanity and the powerful geological forces that shape our world. Section 4. A volcano on the move. The peculiar case of Mount Pektu. Mount Pektu is not your average volcano. While most volcanoes are situated along tectonic plate boundaries, Mount Pektu is intriguingly located in the middle of the Eurasian plate. This unusual positioning has baffled geologists for years, sparking various theories about its formation and activity. A leading theory proposes that Mount Pektu's presence is due to the subduction of the Pacific plate beneath the Eurasian plate, far to the east. According to this idea, as the Pacific plate sinks under the Eurasian plate, it releases fluids and melts that ascend through the mantle. This phenomenon, known as back-arc volcanism, can generate volcanoes far from the plate boundary, explaining Mount Pektu's odd location. The ramifications of this theory are profound. If Mount Pektu's activity is indeed tied to the Pacific plate's movements, it implies that the volcano's behavior could be influenced by distant tectonic forces. This complicates eruption predictions, as scientists must account for the intricate interactions of tectonic forces over a vast area. Mount Pektu's unique location and its possible connection to the Pacific plate make it a captivating topic for geological research. It is a volcano that resists simple classification, challenging our understanding of volcanic mechanisms and highlighting the dynamic, interconnected nature of our planet. Chapter 5. Shifting Plates. The Pacific Plate's influence on Mount Pektu. The Pacific Plate, one of Earth's largest tectonic plates, is a key player in the saga of Mount Pektu. Despite being located hundreds of kilometers to the east, the Pacific Plate's constant westward drift significantly affects the geology of Northeast Asia, including the volatile nature of Mount Pektu. As the Pacific Plate subducts beneath the Eurasian Plate, it carries water-rich sediments and minerals deep into the Earth. This subducted material, exposed to extreme heat and pressure in the mantle, undergoes dehydration melting. The water released from the subducted plate lowers the melting point of the surrounding mantle rock, creating magma. This magma, being less dense than the surrounding mantle rock, gradually ascends towards the surface. Over thousands of years, this ascending magma can gather in large reservoirs, generating zones of intense heat and pressure beneath the crust. Mount Pektu, positioned above one such magma chamber, acts as a release valve, discharging built-up energy through earthquakes and volcanic eruptions. The influence of the Pacific Plate on Mount Pektu underscores the interconnected nature of Earth's systems. Events occurring thousands of kilometers away can directly impact the behavior of volcanoes, even those far from plate boundaries. This interconnectedness highlights the importance of studying plate tectonics and its role in shaping our planet's dynamic geology.